Welcome to the Data Centered Leadership Podcast. Today we have an exciting guest. His name is Johannes Giorgis, and he's the creator of a new data science related course called Acing Data Science Interviews. And he's also a successful early career data science. So welcome, Johannes. Thanks for taking the time to talk with us today.
Yeah, thank you so much. It's a pleasure and honor to talk to you.
So first, before we get into your course, which seems really exciting and interesting, let's talk about how you kind of got into data science, because it looks like you have a not like the most typical data science career. You started in electrical engineering and moved to software engineering, then data science. Could you elaborate on your motivations and your experiences going in this path?
Yeah, sure. So by the time I finished my studies, most of my internship experience was software related. So that's where I went from having studied electrical engineering to a software engineering role. And I started in a tools and automation team where we were responsible for building, internal tools, scripts, a little bit of back-end services. We had an internal website where other operations teams and product teams would see what's happening with our systems and, client information. And after a year doing that, I moved over to a newly formed team called Data Operations. And so our team was created to take over the day-to-day responsibility of our data pipelines. So we had a growing data analytics business at the time. And so the engineers who had initially built out the system were now doing all the operational tasks and issues that come around with, anything dealing with big data and delivering to clients every single day. So our team came around building scripts, getting introduced to Amazon Web Services, big data. We were using Hadoop, we were using Spark. We had to reduce our costs. So a lot of infrastructure provisioning and reviewing what's going on and doing a lot of analysis in the systems to find where we could optimize, where we could reduce costs. And then most recently, I joined a startup to help build out their initial data infrastructure. And it ended up being that they're such early stage, I ended up being part of the core product team and help building backend APIs. We started recently to migrating from serverless to Docker-based microservices architecture. So learning about that, learning about messaging queues. So yeah, diving much deeper into software engineering than data science. And that's been the journey so far. And in terms of what sparked my interest in data was going back to where I was in data operations. We were, as I mentioned, we were in the infrastructure and operational side of our analytics business and interfacing with, the product team, the sales team, and mostly the engineering team who was responsible for building out the product. Every time there was a new product, doing the research. There was a data science team as well doing the initial research. And so we worked very closely in a very cross-team setup. And that's where I started being curious to know, what is it that we were selling, right? What was the end result of what we were delivering every day to clients? And on top of that, more close to home, I spent a lot of time. So there was different parts of our data infrastructure, right? So there was the first part where everything was in our internal databases that we had to be pulled into our Hadoop system. And at the end of the Hadoop system, it was sent off to AWS, where we could take advantage of the Elastic Cloud. We were launching instances and using AWS's EMR, which is their managed Hadoop clusters, to launch our jobs. And then finally, we were delivering to S3 and Redshift for our clients. And so there's parts of the system where we needed to find ways to optimize it, right? Or sometimes we just had no visibility. So although we had done a really great job of building the system and from an engineering perspective, speeding it up, there wasn't, from an operational standpoint, there wasn't a lot of visibility into job metrics, how long stuff ran, where did stuff start, when did stuff end. So I spent a lot of time.
I don't understand the visibility thing. Do you mean like because you were on the back end and you were saving money rather than focusing on getting the company money, there wasn't visibility? Or do you just mean that you had figured out ways to improve things, but you realized you could only improve things a little bit because you weren't tracking your work? You didn't have enough tracking systems in place.
Got you. Yeah, let me clarify that. So what I meant by that was, so the engineering team and like everybody, we did a great job of, with data, it was taking us, there was a lag of over a day or so from where, we were dealing with, to give you a bit more context, financial data. And so there was a lag from when it came into our systems to the point that we, were able to get it out the door, if you will, and get it to our clients. And so one of the big tasks was to really reduce that time. And from everybody working together, we were able to reduce it dramatically by doing certain things. How do I put it? Yeah, by putting certain processes in place, speeding some stuff, getting it to start earlier. So there was visibility. What I mean by that is visibility into a system, right? So the system being, if you have, literally just think of it as a manufacturing pipeline, right? So the very beginning, you have your input coming in, you do something with your input, then you might have a bunch of, in the context of data, a bunch of third-party data you're bringing in. You might be doing a lot of normalizing, cleaning up. You might be enriching your data and then sending it up to the next person, right? And then finally sending it out the door to, as a final good, the data product you're delivering, whether it's files or however you're allowing your clients to access it, right? Mm-hmm. So at a very high level, you could tell like, oh, let's say our input is not going in as fast enough, right? Like we need to figure out the very beginning of our pipeline, how fast we're getting the data from our source, right? If there's such a lag there, right? That like everything else just doesn't get started. And then there might be a case where everything's moving in really quickly. You're getting a lot of data coming in, but then some part of your middle process is taking much longer than anticipated, and you need to go investigate that. So that's like at a very high level, right? But then what can happen is, so at a very high level, we did a great job of reducing it, and we could get it down to within a day, right, instead of overnight. But what I was talking about specifically was, now that you had it at a high level, everything seemed to be okay. Maybe you needed to go to like the second part of your pipeline and start doing some real investigation. So in ours, it was once data came into our Hadoop cluster, there was lots and lots of jobs kicked off, right? So being in finance, we had information that we classified as, credit card data and debit card data, right? And so there was all these jobs related to all of them and classifying this and all that. And what we needed to do when I spent, especially later, right before I left, my last year there, was that spending a lot of time in building tools to capture that data, right? To just say, okay, what time did a job start? What time did it end, right? Just to find out what are the biggest running jobs so that we can find ways to go research why those jobs take so long and then further optimize them, right? So as an example, if something was taking an hour, right, through all this research, or first you have to get the data because we didn't have any metrics. And that's why I meant where our telemetry was very poor. We ended up doing a lot of more ad hoc stuff. Later, near the end, we started building a system that we call Harpy, which started giving us visibility into every stage of our data pipeline by collecting all of these metrics and visualizing them for us, right? But before we had the system, we had to do these things ourselves. So I'd go build tools, primarily in Bash scripting, like shell scripting and Python, to collect this data. Then you'd collect it per day, then you collect it for several months, however much you wanted. Then, of course, you'd have to I spend the time looking and cleaning and summarizing that data to just say, okay, here's, job A, B, and C. Job B is taking the longest. Let's go investigate that. Let's go figure out what's going on there, and then how we can reduce it, right? So that's where, going back to the original question, that's where I started becoming fascinated with data, right? Because say you came in, you were brand new to the team. You didn't know how a system worked, right? And if there was no telemetry information for you, you would have to go build the tools to capture that telemetry data, right? Runtime information, what time jobs start, what time jobs end, and then synthesize it and come up with a summary. And then using those insights and getting more of the, business context, sometimes jobs were set up in a certain way, whether it's performance from the database side, business case, whatever it may be, they may be set up a certain way. Maybe it was historical. We needed to revisit and change those decisions, right? And have those discussions with the appropriate team members. And so once you have that and you have an idea, then you could go back and build more tools to optimize your workflow, right? So I was looking at data in the context of systems and how to optimize and improve these systems, whether it was reducing costs, improving efficiency, and just trying to get more out of what we had. And that's where I was like, this is awesome, right? Because data was my best friend, right? My data was what helped explain to me why one day we did great and the next day there was such a huge delay, right?
Wow, yeah, it sounds like you had kind of it was like a natural flow for you getting into software engineering. Like when you're doing electrical engineering, it's a little bit of a step over to go to a software, but not that much. And there are probably more software jobs. So you kind of like went after it, fit into it, and you approached it from an engineering perspective. It sounds like quickly developing systems, but the company needed data related systems. So it was like a natural flow to get more involved in data. But then it sounds like at some point you kind of had an epiphany where you kind of almost like once you had your system built, you realized you had to go from like the engineering perspective of just looking at the little details and building things, and then switch to the science perspective of studying the higher level systems and understanding how to make the larger components go work together better by using analytics methods.
Yep, exactly.
Wow. That's really
nice. So, I mean, on top of that, so that's the opportunity I had through my job, right? Where you have to understand these systems and optimize these systems. And then on outside of that, I was, taking courses in programming, building on my Python skills, and a good friend and I, we decided to take the Udacity Deep Learning Nano Degree program when it was first announced. And that's when I got my exposure to the larger world of AI and kind of not just, looking at data from the perspective of analytics, but looking at it from the perspective of building products, right? So the deep learning nano degree, introduced us to computer vision, NLP, sentiment analysis, neural networks, convolutional neural networks, GANs, recurrent neural networks. So that was also another great experience for me, because that kind of brought together my previous really strong math background and showed to me, hey, this is a way that I could apply my previous knowledge of linear algebra, of differential equations, of calculus, where now I could see that stuff being applied, whether it was gradient descent, backpropagation, all the math that you needed to really understand how a neural network works was stuff that I was really strong at, but previously did not know how to apply it. And here it was being applied, and that kind of made it click. And of course, combine the development angle of it, right? And that's really what kicked off my data science journey. And that's when I started to realize I wanted to learn more about the AI space. So we finished the deep learning nano degree program, and afterwards I signed into Udacity's AI artificial intelligence nano degree program, and got even more exposure to building more simple products, whether it was identifying a bird, a plane, building machine translation, using computer vision to identify yourself and identify your emotions. So that's what got me excited and into this field.
Cool. So I'm just curious, you said you built something with a Hadoop and then moved on, and you also said something about moving from serverless to Docker. Kind of interested, what's the difference between serverless and Docker? I thought Docker was like I thought serverless just meant running stuff on the cloud. and Docker was just like an easier way to deploy your packages on the cloud, like a way to upload a remote desktop kind of thing, like a virtual machine.
Right. So yeah, so I can dive in a little to that. So in my current company, the technology was proven out by building by leveraging serverless. So specifically Amazon Web Services Lambda service. So to explain serverless before, or even before Lambda was announced, even when you're running a website on Amazon Web Services or Google Cloud or Microsoft Azure, you were using a virtual instance, right? Whether it was most likely it was Linux, right? So you get a server, you log in, you install the web server, Apache or Nginx, you set up your website. Maybe it's a WordPress, maybe you're using Django, Ruby on Rails, what have you, right? So you build your application, maybe let's say in this context, it's a blog, and you deploy it to your server. So, and then of course you do, you set up your domain and you connect it and you secure it. That's still stuff I'm learning to figure out how to do, but let's just say you've set that all up, right? And now you can go to, for example, datacenterleadership.com, and that will route you to your one server, right, to begin with. Yeah. So over time, you just use that. Maybe that's fine. Maybe you're getting hundreds of thousands of views, and that's fine. You don't need to grow anything more than that, right? But over time, there's software updates that happen. There's security updates that happen. There's a maintenance perspective on your instance that needs to happen, where you need to turn it off and replace it, right? So then you're in a situation where you have to manage this computer, right? This virtual computer. And that's where sometimes you can get to more complicated setups where you can have several servers connected to a load balancer, and your load balancer is where you actually hit, and then it'll go to the appropriate instance, so that if one instance goes down for whatever reason, maybe even the underlying hardware, as can happen from time to time with these cloud vendors, the underlying hardware can go down, and then your server's down, right? So that's the situation you would be in. And but now, Amazon, I think it was 2014, they announced Lambda. So that was their serverless function as a service, right? That was their offering. And then I think since then, Google Cloud and Microsoft Azure have released their own. I think there's open source versions out there as well. But the whole premise is like, now you just focus on building your application, right? In the context of this, maybe you now just use like one of these static sites, right? Static site builders, there's Jekyll, there's Hugo. I use Hugo for my personal website, for example. And so that allows you to, to create a website that doesn't need a database, that doesn't need a server. And then you can take those files that are generated and are put into an S3 bucket, right? And then you can link the bucket directly to CloudFront. Yes, CloudFront. And you can use like Route 53. These are Amazon Web Services, different services you can use for this. But basically, if you just to go back, you can now start focusing on your application, right? Nice. And letting the cloud vendor take care of the management of the underlying server, right? So it's kind of like they're just going up. Go ahead.
The cloud didn't used to be really much more reliable than a server. You just didn't have to run a server. Now they have like back-end cloud stuff. So if one server goes down, it just bounces around and stuff seamlessly. So it's way more reliable. So you don't have to worry about backups and stuff as much.
Yeah. Nice. Yeah, more or less. So if you, simplifying a lot of things, but just to provide a more historical context, if you were going back 20, 30 years and you were launching a new website, a new service, a new company, you needed to rent space in a data center, right? Yeah. right? And then and because you're just renting space from the data center, you need to procure the server, right? So you'd need somebody or a team of people to manage those servers. Servers could go down. So you were actually responsible for the physical server itself and all the way up to your website, right? How people log in and the entire experience. So, but then with the rise of Amazon Web Services, you no longer need to run a data center, right? And I'm sure you've seen tons of articles of now even banks are starting to close down their data centers and move into the cloud. So now lots of companies are moving that way, right? Where it's like, why do I need to take care of the physical server? Because the cloud vendors, having managed and taken advantage of the scale, they can deal with all that headache, and I can just procure what I need. It's like electricity now, right? Where, you know, that's the example I give people. Hundreds of years ago, maybe you needed to run your own generator right outside your house, right? And if something went down, you'd have your own generator. But now, right, you use whatever electricity you have, and then you get a bill that you pay for, right? Same thing for water and internet. And that's basically what the cloud vendors have turned the servers into, right? At the very base level. And then what they've done since then is start building services on top of that, right? Managed databases, all kinds of different databases, managed storage. S3 is a huge one, right? And then now it's this whole serverless concept, which is I will make you, the client, not worry about the underlying server. Like, matter of fact, you don't even need to know what happens. You just focus on building your application, your API. So in the context of data science, say you built a model, right? And you want to make it available. So now you don't need to worry about the server or anything. You can just have the model and the API, right? Like your Flask or, your Python. There's a bunch of them out there, but let's just say we use Flask. We set it up. And then we can just deploy it to Lambda on the AWS Lambda, and then use, I think, API Gateway to expose that. And that's all you have to do, right? That way you don't, API Gateway is one of Amazon's services for managing APIs. And that way you can link it to your specific server, to your specific Lambda function that you've created that has your model. And then that's it, right? You expose your API through your website or through an endpoint, and you can say, hey, hit this API, and you will actually be interacting with my model that I built, right? And during this entire process, you're never touching a server, right? So that's the power of that. So Docker, on the other hand, is, so Python is a great example of this because Python's packaging story isn't quite there yet. It's actually a big hassle. I imagine if you've done anything with Python, like, so, you're starting a new data project, you have to install NumPy, you should install probably Pandas, Matplotlib, SciPy. Well, no, you do, but you use either Anaconda. Conda is a great solution for this. Conda and virtual environment, right? So that's fine, because Conda solves the problem for you on your computer, right? And yes, you can create the YAML file, the YAML Conda file, so that you can send it to a colleague to say, hey, this is the settings I had, or you tell them, here's the packages to a requirements.txt file, right? But I've often had a lot of unsuccess doing that, right? Especially if you're switching between like a Mac to a Linux to a Windows. Sometimes in the Conda or the pip packages, they install things that are specific to the OS, and that ends up breaking things. So I've had situations where I've had to like kind of clean up my conda.yaml file to make sure it's cross-compatible with others. It's a real pain point.
Wow.
But yeah, so so you have that pain point at that level. But then let's say you built your model, your analysis, something that will be deployed. So more of an API versus like a Jupyter Notebook analysis that you can just print out as a PDF or an HTML. So in that case, then you need to be able to deploy that to a server somewhere, right? And make it available as an API endpoint for, other teams to access, or better yet, give that somebody else so that, a colleague can go test that and verify that the model does what you expect it to do, right? And that's where now Docker can solve that problem, right? Because Conda sometimes has these challenges
Oh,
So yeah, so I think if you've played around with Conda and then you've tried to go and install it in a separate server and try to make it available, you can kind of see sometimes it doesn't always work. I've found cases where if you've used an older, like say you had a Conda package, a Conda environment from like 2 years ago, right?
mm-hmm.
And then you try to recreate it. Sometimes it fails because those packages are so old that they're no longer available, right?
Yeah.
So with Docker allows you to, how do I put it? It creates a consistent environment for you, right?
It's not a virtual environment?
So it is it is compared to, so that conceptually people can understand it. It is very similar to a virtual environment, but it is not like a virtual. It is not a virtual environment.
What
right?
is it, lighter weight?
Yeah, exactly. So it's lighter weight. It's the concept of containers. Docker's just become the most popular one. There's a bunch of others out there now, but yeah, without getting to too many details on the technical side, what Docker allows you to do is because so in my current company, that's where right, as I explained, we were moving from Lambda and serverless framework to Docker-based microservices, right? So then now what the whole idea is, like, you have your model endpoint or your endpoint to interact with a database, a CRUD, right? You create, read, update, and delete records. API, you put that in a Docker image, and then you deploy that Docker image as a container using Elastic Container Service on Amazon. There's also a bunch out there like EKS, Elastic Kubernetes Service. And of course, Kubernetes is the de facto now to manage multiple Docker instances when you start getting larger and larger infrastructure. But at a base level, going back to Docker, what it allows you to do is put everything, like, you can install Conda in it. You can just install the packages you need. The idea is, like, you want to actually keep your Docker image as lightweight as possible, because if you have like Python, and I think like official Python one's like at least 600, 700 megabytes, which is pretty large for containers. So you want to get a lightweight base image that you can pull from, and then you use that image and you install the necessary things that you need on it, right? So, you can pip install, first off, install pip, right? If it doesn't come with it. Then you can pip install, the pandas, the NumPy, whatever your project specifically needs through your requirements.txt file. And then you can load all the source code into it and expose and run your Flask app in that Docker image. So you create a Docker file that's basically the recipe for creating your specific image, and then you create that image, and then you upload it to either, if your company might have a private repo, Docker repository, right? The same way you might have you would have a private like Git repository in your company, right?
Yes.
So same way as that, right? So either you can do that, or you can put it in, I think it's the Docker Hub for your own personal, if you don't, there's nothing proprietary and you're just building your own projects, and make it available for people to download, or run your own private Docker repository. So you create an image, you have this Docker file that's a recipe for your image, and then you can upload that image to a Docker repository to make it available for other people to download and run exactly your service the way you intended for them to run it, right?
Yeah, it sounds
so
really convenient.
I hope that clarifies that difference.
Yeah, thanks for clarifying that. There's so much to know about data science. I mean, so many things are called data science. It's within this emerging field, so much knowledge. It's like a completely different side. It's really interesting. So, what in your, you've been studying data science for a while, you've been kind of like building data science infrastructure. What would you say is the most, out of all the things you've done in the last like 5 years or so, with regards to projects and everything, which project would you say that you've done is the most interesting, and what kind of packages or technical concepts that have you used? Uh, Basically, what I'm saying is, what have you worked on that you felt like was the most valuable, like that's interesting to share, and what software or technical concept did you use to reach those like valuable uh, ends?
Right. Sure. So I think I actually have 3 projects in mind, so I'll try to keep it short for each one.
Cool.
So in my when I was in the data operations team, the data that was coming in our pipeline was all our own company's data, right? It was coming in from our own internal databases and going to our Hadoop systems and all of that, right? So and it was, of course, being enriched and then being sent to our clients. So we had a request that came in from clients that said, hey, you know what, this is great and all, but I have my own data that I want to enrich using your algorithms and your proprietary methods. How can I get access to that, right? So that request came to my team, and it so happened that it was just my boss and I that worked exclusively on this project from a technical standpoint in terms of operationalizing it. So there was engineers that had built already the initial product. So this specific project, what it did was it took financial data and it added and enriched it with geographic information. So as I mentioned, we were only doing this internally to our own data and then making it available. So this client wanted us to do it for their data. So this requires them to send us data for us to pick up that data, enrich it, and send it back. Mm-hmm. And the legal and business team, being who they are, made it, I think they initially talked about like a 1 hour turnaround, which if you've dealt with like any cloud-based infrastructure, sometimes Amazon does go down. Sometimes instances, because they're popular, are not available. And in this particular case, it was a different region. And there were times when, in that region, people were waking up, business was waking up and, getting ready with their daily workloads where our stuff could not even come up, right? So this project was super cool because up to this point, even though we were using the cloud, we weren't taking full advantage of stuff, the cloud, meaning you're not supposed to, it's a pet versus cattle mentality that people talk about when it comes to the cloud, which is, going back to our earlier example of one server, you start treating that server as your pet, right? You're taking care of it, you're maintaining it, you're always making sure that it doesn't go down, freaking out. But in reality, the power of cloud is that you shouldn't have to do that, right? Mm-hmm. You should just treat them like cattle. You launch a whole bunch of different, multiple instances, right? Multiple servers. And if one goes down or 2 go down or 10 go down, you shouldn't care, right? Because it will bring it back up and you just need to build your service in such a way that it can handle that load, right? And so up till that point, we weren't doing that, but this required us to actually do that, right? Because say if I launched 5 servers and like 4 of them couldn't come up, or even 5 of them couldn't come up for whatever reason, I would not be able to, turn around. So to provide the better context, because our client can send our data any time of the day, we can just have infrastructure running 24/7, right? That didn't make sense. So the whole challenge of this was we needed to build a system that could pick up, a file and launch the infrastructure needed to process that file, verify all the infrastructure came up in time, and as soon as it came up, send the file over to be processed, verify that the file was being processed and there was no processing issue, and then of course once the file was completed, send the output file back to the client and verify that it was received on the client's end, right? So that was what was super cool, because now I had to start thinking like, okay, I need to make sure just a percentage of my servers came up instead of previously it was like our alerting system was based on 0, 100, either everything's up or everything's down, which again is not the case when you're dealing with cloud, right? You have to have that flexibility of saying, as long as something is up, it's okay, I need to keep moving, right? Um, and of course, all the challenges of like now it actually became like a factory, right? Because if multiple files were sent, we had to think like at every single stage, what would happen? How do you handle like a corrupted file, a file you can open, a file that failed to process, right? You can block if your first file fails, you can just have your infrastructure running 24/7 without alerting you or failing to alert you, and have the files behind it get stuck and not get processed, right? You at least have to isolate that file, notify yourself, and process the remaining files and send what is successful, and then isolate what's not and send you a report for each one, right? So that was a really cool one, building that system in a short period of time, learning the value of like thinking ahead, designing. Like we were using the Microsoft Visio to write out all the steps that could happen, right? The workflow of files received. Is file processing? Is file not processing? How do you handle failed jobs? How do you handle successful jobs and all of that? So yeah, that was one really awesome project. Another project that was really, really enjoyed, challenging in multiple ways, was the one where I referred to earlier, where I spent basically my last year in my previous company doing all the research needed to optimize the Hadoop part of our system. So specifically how we were getting data from our databases into our Hadoop system. Wow, excuse me. So we needed to, so that took like months. There was, multiple parallel jobs. There were several pipelines that ran in parallel. Each of them had to be investigated. The ones that took the largest had to be identified. And then this is where a lot of conversation had to happen with multiple teams. You had to talk to the database team to figure out why jobs were set up the way they were. Sometimes it even went down to where physically the databases were located with each other, right? So if two databases were actually in the same physical area or same physical box, I'm sure that they weren't hopefully in one server, but you can just run more parallel jobs, right? There was a limit to that hardware. So getting to that level of really understanding where stuff was and how you could further optimize it was a great project. Tied to that was where we started building the metrics collection, the heartbeat system. And so a lot of the work that I went into, like building those ad hoc scripts, came into play where we put that all together and to build this heartbeat system, right? That would show us everything from how we were getting data into our Hadoop systems, all the way to the files going from Hadoop to Amazon, how our Amazon workflows were going, all the way till client delivery, right? And so it was one place that you could see everything, where before emails from different systems were sent, and it was a little bit of a scattershot. So that was really a great project.
So many moving parts to keep track of.
Yeah, exactly. So that's what the value of our heartbeat system was, right? You had one place that you could see the entire pipeline, where you were at for each one of your files. And the third project was my most recent, where I mentioned this move from serverless to microservices. So I ended up building, in actually a couple of days, we had a pipeline to process our receipts, right? So we have an IoT device that's capturing receipt data, sending it to our cloud, and then we're parsing it, OCRing it, and saving it to a database. So we had several Lambda functions set up, right, you had the input, the preprocessor, sending it over to the parser, sending it to another task, and then saving it to a database, right? So you had a very linear data pipeline. So I converted all those into a web service and put that web service into Docker. And then with my colleagues' help, we were able to use Amazon's ECS, Elastic Container Service, to push that Docker image to our Amazon services and then deploy it and see it run. And then we did it.
So is this like a check recognition system or something like that? Like people take a picture of a document and then, so you deployed at like a massive scale, something that automatically turns picture into useful digital information. Is that what you're saying?
Yep. So in our context, we were working with retailers, right? So we were getting receipt data from their POS systems.
Wow.
And so some of this, I think it was, in our case, it was so far one specific client that was, that the printer system, it was coming in as an image. And so we had to do OCR in the cloud.
Wow.
And
That's
so
cool.
we did that.
That's really cool.
Yeah, exactly. So yeah, basically putting that all together, and we ended up creating 2 microservices so that we could handle both historical processing and incremental, right, every day coming in processing. And so that was very, very insightful. I basically built my first web service. So that was really exciting, very enlightening. And yeah, that got me really excited about, first off, building just web services in Python to begin with, how straightforward they are, right? You use a route to point to your function, and then your function and the way you structure your repo, right? Your project. And then of course, deploying it and seeing it run, testing it locally, tying it into Docker. That was really, really cool. So,
that sounds cool.
Yeah, those are the 3 projects.
Cool. Thanks for sharing, Johannes.
Yeah, absolutely.
So yeah, it sounds like you've been working at the cutting edge of data and cloud infrastructure for a number of years now, and you picked up quite a few things along the way, and that some of the things you've learned along the way have helped you to arrive at creating a data science interview preparation course called Acing Data Science Interviews. So could you share a little bit more about how you like your motivation and how you came across this or thought of this opportunity?
Yeah, absolutely. So going back a little bit, as I mentioned, I took a couple of Udacity's courses, and through taking those courses, I was introduced to Vim Marsh, who started the Acing AI Medium publication.
Nice.
And yeah, he had several articles out there going over the interview questions for different companies. You have the typical tech companies, startups. I think even a couple of banking firms. And so we connected, and I stayed in touch with him, and I offered to collaborate with him. And I think it was basically the fall of 2018. He shared with me, he had a bank of like at least over 100 questions that he had pulled from doing all his research. And we started thinking, okay, how can we use these questions, right? So we first started by creating a question answer bank, trying to answer the questions, and because what he was doing was basically writing and listing out all the questions that you were going to be asked or expected to be asked in these different company interviews, but there was no solution to them, right? So we started working on answering these solutions, and we wrote a couple of blog posts on them, and that's what led us to this. Well, that's one of the reasons that led us to this idea of building this course. So the other thing was we saw the rise of course, data science, the rising popularity of the data professional. The jobs are there, right? With business analysts, data analysts, even folks who don't necessarily have the data scientists in their title, data engineers, machine learning engineers, right? So we're seeing these reports from LinkedIn every year, top jobs, data science, machine learning engineer, and all of that. And so with that, there is, of course, been this rise of data science boot camps, like there was several years ago, the rise of software engineering and coding boot camps.
Yes.
But once you go through a boot camp, right, sure, data science or, some techniques, and maybe you can solve some problems, but that doesn't prepare you for the interview process, right? And so where software engineering, there's a pretty clear path to what you need to do for software engineering roles, right? There's really famous books like Cracking the Coding Interview, Elements of Programming Interviews. There's so many books and resources out there. And if you're just willing to put in the work and study, and, there's, HackerRank and LeetCode, so many resources out there. And some of these companies, they'll even share with you resources to prepare you for their interview process. That the software engineering process is pretty straightforward at this point, right? If you're willing to put in the hours and cover the material the way that's best for you, then, you have a clear path to getting into the big tech companies. It might not be your first or second try, but people keep at it, and in their third or fourth, they get in. It's not their first or second, right? But well, it's pretty clear for software engineering, it is not the same for data science. Data science interviews are nebulous. I think from some of the podcasts and some of the anecdotes I've heard, a few years ago, if you just knew a bit of scikit-learn, some pandas and NumPy and a few of the R-related data science packages, it was a pretty straightforward shot to getting a job in the industry, right? But now I think the bar has been raised quite a bit. And, there's so many roles, right? Like you can be a data scientist, you can be a data engineer, you can be an analyst, but even more granular, there's research scientists, there's folks who are more on the applied side, there's folks who are more on the research side. You can be at a large company, a small company. There's so much range, right? And now there's elements of data science that are incorporating software engineering, right? Like folks who only coded, in the context of doing some data analysis are now expected to learn algorithms and data structures and are being asked as, their part of their first step to work through HackerRank questions, and they're encountering them for the first time, right? So going back, data science interviews remain pretty nebulous. And so this is where Marsh and I saw an opportunity to package the questions he'd been gathering and we've been working on answering into something more meaningful with a little bit more technique, a little more framework for to show people how to approach the different questions you're expected to ask. Everything from coding, statistics, basic machine learning algorithms to, machine learning systems, which kind of takes from systems architecture questions in software interviews. And so and then of course a more soft side of how do you approach these interviews, depending on what role and seniority you're going for, what format it is. So for some, you might have to do a case study. For some roles, you might have to do even a presentation. You're expected to do a presentation in front of a team of folks to see how you can communicate. Others, it might just be more coding, more a case study of doing some an analysis, a take-home analysis, right? So it ranges. So we wanted to put this together and offer it to people.
Wow. So there's just so much information. I know it's really incredible. A lot of it depends on the role too, I think.
Yeah.
It's still not well defined, but at least they're coming out with like new terminologies, like data engineer. Because before they were saying data science is 80% getting your data ready. And now they're saying data science is something else, but data engineers just focus on the data. So at least it's getting divided up a little bit. I guess that's a good thing.
Yeah, no, exactly, right? Like there is the now specialization, right? The start of specialization that folks are starting to refer to, right? Even the machine learning engineer role is, people frame it as a more recent role that's come in to sit between the data engineer and the data scientist, where you may not necessarily be responsible for coming up with new models the same way a data scientist is, but you have more of a software engineering background, and you can, or sometimes even a DevOps background, and you're able to operationalize your models, right? Whether it's building web services and deploying them, scaling them, and making them performant, right? So it ranges, but So
I didn't even realize that was what a machine learning engineer was. I thought the machine learning engineer was like the neural network specialist, and the data scientist was the overall model generalist with specializations in statistics and math. I guess.
And I would say you're not wrong. Again, it goes back to how large your company is, what stage of their their journey in data analytics, AI they're in, right?
Mm-hmm.
Yeah, there's again, right? There's so many anecdotes. There's not necessarily a right or wrong answer. Every company is different. And so, yeah, you're not wrong. is all I need to say. I'm sure machine learning engineer is probably expected to know that versus others. The one thing I will say that I've noticed is deep learning isn't, of course, there's a hype train around deep learning. It is a valuable skill to know, to be aware of. But at least from what I've seen, unless you're working at, the Amazon, the Google, the Apple, and the Facebooks, and Microsofts, and very, very large companies, or even non-traditional companies. Like the other day, I was listening to a podcast about Shell and how they just built a data science residency or AI residency.
Cool.
So unless you're working at these really large companies that have massive amounts of data, and where maybe deep learning can play a role or is already playing a role, right? Like we see those articles from Google talking about their performance and all that. Or you're a startup, trying to find a niche application of deep learning, whether it be medical, manufacturing, even reinforcement learning to a certain extent, it also falls under that camp, in my perspective, where it's not mainstream yet in the sense like every small business or medium-sized business is trying to utilize that. It's just unless you're a startup trying to solve a new problem using these really cool cutting-edge tools, or you're a very large company that has the skills, the abilities, and all the infrastructure in place to tackle and take advantage of them, right? Deep learning and reinforcement learning aren't quite there yet, right? So just my 2 cents there.
Yeah, it's not. It's really a specialized thing. Like, there was definitely a lot of hype around it where people thought you could just throw it at anything. But I mean, at least from my studies of deep learning, and I mean, maybe I don't understand it well enough, but like in my attempts at application, I have not been very impressed with the results.
Yeah, right, like exactly.
I've been finding a lot more benefit from just kind of knowing how to quickly process the data and put it into something where I can put it into some kind of simple model. And then having a good way of visualizing and testing to see if that model helps me achieve some objective. Those things have been helping me dramatically over like the last year. And like the machine learning stuff that I spent so much time learning, I mean, like knowing a little bit about some of the machine learning models has definitely helped a lot, but like the specific stuff that I did for like neural networks and stuff, I mean, at least in my field, I haven't seen much use in it. Like it's just like one part in the toolbox right now.
Yeah, exactly. That's my anecdote as well, right? I think you're better served learning, linear regression, logistical regression, the more traditional, what they call traditional machine learning methods, statistical methods, and of course, how to clean your data, future engineering skills rather than necessarily the deep learning skills right now. Unless, of course, again, if that's what you want to focus on specifically and are targeting those companies that specialize and have those opportunities, it's just you're better off learning about data and machine learning. Just as you said, right? That's where you'll get more value from a career and opportunity perspective right now.
Interesting. That's so you've really been studying this. I mean, and it sounds like at the point we're at right now, it's not enough to just try to learn some Python. I mean, like that's what I did. That was one of the things besides getting a degree that helped me to land my job. But at this point, it's getting a lot more specific. And from what I'm understanding from you, it sounds like you almost have to take an entrepreneurial mindset to find to find a job and to choose how to prepare yourself for the job, like maybe look like finding some target companies and target positions, then studying for those specific things quickly. Like,
Yeah,
I mean, because you can't learn everything.
no, definitely not. So this is where, I encourage you to of course, do your own research. But there are several blogs I really like to go back to and read up on or follow. So not necessarily endorsing their product, but Elite Data Science has some great blogs, posts about, some are technical and some are about career. One is very specific is, I think it's how to get your data science job in 2019 and 2020. I think they just keep updating the title, but they have a more kind of take a seat back and think approach, where they just say target like one or two industries. Like they have like a 5-step or 6-step process, but target a couple industries, go look up some job roles, highlight some common technologies and tools that you see often. So, probably you'll see Python, you'll probably see, machine learning, maybe Spark if you're doing something data engineering related, right? What have you not? And then list out those 4 or 5 skills, technologies, languages, and then just study one continuously for a couple of weeks until you become pretty proficient at it. Then go to another one, go to another one, go to another one. And then once you have enough, or you're comfortable enough, you've built some projects under you, you can start applying for those jobs, right? So that was a great approach and because it can be overwhelming, right? There's so many jobs out there. Maybe one will mention like a C++, one will mention Scala or Hadoop, and then each of these is huge, vast concepts that you can spend years learning and not be quite an expert in, right? So just limiting what you need to learn and just focusing on a couple things at a time, if not just one thing at a time, is one approach. Another great blog post I follow, Sharpest Minds. They have a great series of blogs where they talk about different things. They highlight different students, how they were able to get jobs based on projects, and how, every time they were at a recruiting event or they were talking to a manager or, they were socializing, they were able to point to their GitHub and say, hey, I'm working on this project. This is where I'm at. This is the stage I'm in. This is the challenge I'm facing. And in some cases, they were able to get hired without even completing their project, just by showing that interest and that level of passion, right? Because that's basically what you're going to be doing at your work anyways. You're going to go in there, you're going to find a way to get that data, to clean that data, and to make sense out of that data, and then build a product based on that data. So,
what did you call that one? Shaka?
Sharpest Minds.
Oh, Sharpest Minds. Okay.
Sharpest Minds.
Nice.
Yeah. Nice. So what I can do is I can share these links with you afterwards, and then I don't remember where exactly this one. There was a blog post on this as well. Maybe it was on Towards Data Science, which is another great resource for blogs as well. But they were saying, like, how long should you learn, right? So the sooner you learn enough to get a job, you'll learn much faster when you're in the job and doing something 40 hours a week versus trying to do something on the weekends and your evenings, right? So you should try to learn enough to get a job as soon as possible, and then your learning will skyrocket, right? Because then, you'll be paid, for 8 hours a day to go look at this stuff and build stuff. So yeah.
And of course, they can always. Somebody who's looking for a job can also go to Acing Data Science interviews and get these things curated for them, right? That's
yeah.
And also get some leadership, some guidance, because you do hands-on guidance and stuff like that too, right?
Yeah. So I was involved in an AI meetup here in Vancouver, the School of AI, which was a Suraj Raval's initiative. So yeah, I was involved with the Vancouver chapter, and I put together a few meetups where we did hands-on, we did command line. I was part of a 3-part series where we looked at a Kaggle competition, which was the toxicity comments, where the first part we did some NLP pre-processing. The second part we did building a model to identify how toxic a piece of text was, and then the third part where I led that with the colleague, where we built a Flask API for our model and then deployed it on Heroku with I think we used I'm forgetting exactly what we used, but where we built a simple front end where you could type some text and hit enter, and then it would tell you and give you, different color reaction on how toxic or non-toxic your comment was. And so what I learned from that is there's people do value something that they can see and share with people, right? Versus, if you're just doing an intro to Python, for example, there's so many intro to Python, intro to Keras. There's a bit of my gripe with all the tutorials online, right? It's like, there's so much of like, here's an intro to this, which has its value. But then what I like to see is someone who will take me and not just show me how to build like a model using Keras, but then, deploy it, make it accessible for somebody else to use, somebody else to go visit, right? So, and that's where I saw with the meetup, right, where people really valued one, as you said, the hands-on, right? Sometimes you could just even use Google Colab and go build a simple computer vision to identify, dogs and cats, for example, and using transfer learning so you don't have to build a model from scratch. But then, okay, take that and then make it available through a web service or a website or an API, and then show it to other people, right? So, that's where I'm thinking how can we build content and tutorials along this line where we build, kind of mini projects and make it available and easy for other people to see what you built, right? Versus just another, hey, now you have a model, that's it. But in the real world, that model has to go do something, right, for it to be valuable.
Yes.
So, yeah.
Cool. Wow. It sounds like you're really learning a lot, and you've been doing this kind of leadership for a while now. You said you organized some of the meetups and led some of the projects, right?
Yeah. Wow. So, put those together, go explore a topic, come up with a way to present it, hope people show up.
That sounds like a really rewarding way to develop your skills.
Oh yeah, it was. It was a great way to be put on the hot seat and come up with, go do your research and put together something that you can, present and walk people through, right?
Yeah, cool. Thanks for sharing.
Yeah, absolutely.
Wow, you've shared so much valuable information today. Thank you, Johannes. It's
a
lot to think about. It's definitely clearing some of my perspective on the data science field.
Awesome.
Is there anything else you'd care to share?
So there was, this going back to your project. So this wasn't something I did at work, but something I did in my own free time. Was I worked with a good friend of mine where we were challenging each other to come up with, data software projects, and we came up with the meetup analysis. So what we did was, I'm based here in Vancouver, British Columbia, and he's based in, San Francisco Bay Area. So we decided to go explore the Meetup API, specifically look at tech meetups in our respective cities, and explore, explore the tech meetups, right? So we gathered all the tech meetups, each of our cities. We saw how frequently they met, how many guests they had, and, their proximity, and, trying to compare why some meetups had much larger attendance and much larger members versus others. So for my case, I looked at where was like the top 10 or top 10 based, right? And then I noticed they tended to cluster around downtown, which would kind of make sense, right? A lot of people come and work in downtown. Even people sometimes come from like the other cities into downtown just to attend some of these meetups, and just kind of shows you the power of being central and close to where all the action is. And as well as, then we saw like how often they met, how often people showed up, and the attendance over time. And we summarized it to the three best that we would recommend. Mm-hmm. And so we both wrote articles about that, of our analysis. Our Jupyter notebooks were pretty detailed, but we kind of summarized it into a blog post and put it on our website. And then there was I will. The name is in my tongue, and I can't think of it right now. But I'll share that with you, and I'll share you those blog posts with you. Redpanda.ai. So that was another Medium publication that my friend started. So we posted it there. I posted it on my personal website as well. So that was pretty exciting. I think we talked about that during Data Science Go. Part of the motivation for that was I was new to Vancouver. When I was in the Bay Area, I started using meetups, and I found them to be a great way to meet people and connect with people, like-minded people around different topics. I did Toastmasters while I was there. So when I came to Vancouver, meetups was one of the first venues I started to explore, to find, data meetups, software, tech, entrepreneurship meetups, and that's how I made some very good friends. So that was and I think that was some of the discussion that we had at Data Science Go, right? Where when people move to a new city, that was one way to explore. Sometimes the meetups that you saw from afar, like, online before you move, they look awesome. You sign up and then you show up and realize they haven't been active since last year, which is really disappointing. And meetups filtering just leaves a lot to be desired. So I wanted to be able to filter by, how active they are, how often they meet, so that I could, go and actually meet people instead of just saying, oh, this meetup hasn't met in like 6 months and I have to wait another, or God knows when they'll meet again, right? So that's what prompted this, and it ended with analysis. But after I chatted Data Science Go, people were kind of interested in like a web service that they could actually use to find events and do better filtering. So yeah, that's like one project example I'd like to probably explore when I get some time.
Cool. That's that just shows the power. I mean, I'm doing a similar project. I did the IBM Data Science Professional Certificate on Coursera.
Oh, nice.
And it's the most helpful thing I've found. Like, it's helped me a lot in my job. If I would have done it in graduate school, if they had it, then it would have helped me a lot. Because when I first started it, I was looking at computer vision stuff because I was trying to deal with difficult images, difficult to analyze images and analyze them a certain way. But like the technology, I mean, the scripting helped me some with the pre-processing of the data, but it didn't really accomplish what I wanted. And like, I mean, it was just so specific. And similarly with the deep learning.ai and machine learning specialization, it's like so specific. It's pretty exciting, but it's like, okay, I mean, I can use it for something, but then when you get into like these more general data science things like this IBM data science course, and just getting really familiar with some of the pandas functions and the plotting functions, and then you just find an interesting project to look at it. I'm looking at real estate prices and venues. And I mean, it's like, you just look at that. I mean, you could get some really valuable information from like finding the right API and knowing a little bit about pandas, rearranging the data a little bit and plotting it a certain way. And it's just like, it's really enlightening. And I mean, the implications are pretty dramatic about what you can do to use it to make more informed decisions. That was
Yeah.
probably,
No, I mean, absolutely. Again, it's like when I took Udacity's deep learning, I think they've changed it and I'm sure they've made it much better. It was a great beginning start, but my kind of gripes with that was similar to yours, right? Where at the end I had this Jupyter notebook that could identify dogs and cats and airplanes, or could translate some English text into French and French into English, but that was it, right? I was like, okay, this is great, but when I go back to my day job, I can't really apply this, right?
yeah.
And this isn't something I can make accessible, right? So going back to the real world, right? It's like, okay, you built a model, great, but it doesn't. A model is there to solve a business problem, right? The same way that software is there to help solve a business problem, right? So how do you make that model accessible, right? How do you then take it from your computer to somewhere that anybody can go access and take advantage of, right? So that's what I felt was a missing piece. I think their artificial intelligence nanodegree did a better job, where you did kind of end up closer to building a product at the end.
Nice.
But it was still not something you could deploy. I think they kind of added some stuff of that in the data science nanodegree they launched last year, but I don't take it, so don't take my word. But I think that was part of their curriculum. They had a little bit more software engineering included. But for me, I took the data quest I was working through the data science and data engineer path for data quest, and exactly like you said, right? The pandas. I mean, you start with NumPy and then you move to pandas, and honestly, I've never looked back. Anytime I have some data and I'm curious. So another two projects I worked on last year just for myself, so kind of mini projects, was I like gathering information to one place and being able to see in a nice, clean way. So one was I was really curious about was like all of Udacity's courses, right? If you go to udacity.com, you go to udacity.com and you go to the catalog, you can search, you can filter. I don't know, maybe it's my website, maybe it's my browser. There's something that's just lacking where I just like, they have their whole card thing and you have to scroll up and down. And I'm just like, can I just not get just one list of everything you offer and I can filter out myself? So, I use Selenium and a little bit of JavaScript mainly Python and Selenium to go to Udacity, pull all their courses, pull all their information, scrape all of that, and then just, of course, then when I had it, I just had like this list of lists or dictionary of all this information, and then, there was pandas to the rescue of, let me explore this data, let me clean up these things. I don't really care about this. I just want to care about this. Is it free? Is it not? And then at the end, just output it out as a CSV file, right? Dated and everything. So then I ended up with it's actually, I can share the repo. So there's this script you run, Python script that will go through, pull that information, and you'll get a CSV file. The other one was PackPub. PackPub.com is a great resource. They always have these every day they have a free book they're giving away. So over time I've collected several, and I have this catalog that are like several pages. And of course, again, same thing. I can't see all my books and my videos in one page, and it's frustrating having to go from one page to another, trying to identify, okay, which course am I really interested in? I want to see this organized. So that's actually the one I first started with. So again, using Selenium, but this time I had to actually log in and interface with it, versus in Udacity, you just go to one page and pull everything. So yeah, that was like a weekend project where I pulled all that. And again, with PackPub, a product could be a video or a book, right? And then you have to grab that information and then clean it up, right? Again, pandas to the rescue, explore that data, clean it up, reformat it a bit, and output it as a CSV file. So yeah, and then even going back to my last role, I was using pandas.
I like the way you I really like the way that you go and do something and you start working on it and you like just jump into it and start making progress, but then like pretty shortly you kind of stop yourself and you're like, okay, I've made progress, and now what do I do? It's almost like you're not afraid to like jump in and start doing stuff, but at the same time you also know how to pause and like do like a meta analysis of what you're doing. I mean, it sounds like a pattern in what you've been that you've been doing through your entire career, like with the your software job where you jumped in and built the platform and then stopped and did a meta analysis, like a data science thing, and then you with Meetup you started jumping in and doing meetups and Toastmasters, and then you kind of stopped and did like a meta analysis of the meetup, and then you did some Udacity courses, and then scraped Udacity and did a meta analysis of Udacity itself. And that's really awesome. I mean, that seems like a valuable part of the entrepreneurial spirit. Like, I mean, I think that's probably going to serve you really well as you go in your career. It seems really important, like to not be afraid to jump in and start doing new things, but then also to be ready to adapt quickly and like pay attention to what you're doing and the feedback and find a new way to do it better quickly. I mean, that's like, hats off to you. That's really impressive.
No, thank you. I appreciate that. But just as you were saying, right? Pandas is great. Being able to even plot and do basic plotting even within Pandas without even touching Matplotlib is fantastic, right? You get to explore. And then as you said, right, using there's tons of data sets out there, right? But sometimes you need to be able to interact with an API and pull that information and then explore that data and then clean it up and all of that, right? So I find more the basic data analysis skills and tools to be much more handy for me on a day-to-day basis, whether it's in my job or even just, hey, I'm curious about this. I want to explore this and make some sense out of this data, versus like the more computer vision and NLP stuff that you go through in your courses, right? Unless again, you're using that in your day-to-day job.
Mm-hmm. Interesting.
Oh.
Cool. Thanks for sharing. Thanks for taking the time, Johannes. It's been a really nice discussion.
Absolutely. Thank you so much for taking the time to chat.
All right. Have a great night. Bye.
All right. You too. Have a good night. Thank you. Ciao.